function or ceiling functions. Step functions, those are the step functions too, like the other one, greatest integers function, but those are least integer functions. So now this function we can denote with f of x is equal to this denotation here. When we see here in a ceiling, we see we have a little bit like a small line here, and here is a small line. Probably we can see it clear. So if we are looking again here for the domain of the function is from minus infinity to infinity, like it was for the integer functions. If we are looking for the range, the range includes all the sets of the integers. So I think this is the same like we did with the greatest integers. So if we are looking for the x-intercept is from the open closed interval from -1 to 0. So does not include -1, but any number that is smaller than -1 includes up to the 0. And y-intercept is just here, y is equal with 0. Here is the y-intercept. But again, as I said before, and in this function here, the main point, the bottom line here is how to evaluate the least integer functions or ceiling functions. And now we have a -1.5. How we can evaluate instead of a -1.5? So I'm using this symbols or this denotation, -1.5. How we can find -1.5? -1.5 is between -1 and -2, so it's here. And we are looking again, now we are looking at the closed. Where is the closed? Here is the closed, in the ceiling in this case. Here is the floor, here is the ceiling. That's why we call it sometimes a ceiling. Here is the beginning, here is the end. That's why we call in here the floor, and this one we call the ceiling. Even though maybe it's not a very, very technical term, but I think it is some made up term. So if we are looking here, -1.5 is in between, and here is a closed. If we are going up, is a -1. So this is a -1. Now I'm going -3.5. -3.5 is in this interval here, between -3 and -4. If we are going down here, and we looking down, the closed interval is in this point, and if I'm going up, it's going to be -3. So it's -3. -3. And then now I'm going -0.5. -0.5 is here somewhere in this interval, -0.5. But I'm looking now, where is the ceiling? The ceiling is a 0. So because it's a 0, I am writing here a 0. 1.7. 1.7 is between 1 and 2. Is here. If I'm going up, it's going to be here somewhere. And now the ceiling is in this position. This is a 2. So 1.7 is 2. So now I'm taking the between 1 and 2. I'm taking the greatest integer. 0.5. 0.5 is between 0 and 1. If I'm going up here, now is 1. So this is 1. So we have to be very careful when we have to find the values of the greatest integer and least integers, because they give different values. And 3.5. 3.5 is between 3 and 4. And if we are going up here, we look and here is a closed. Here is a closed, it's here, and I'm going in either way. Here is 4 in x-axis. Even if I'm going in the y-axis, as I mentioned before, it goes to 4. So it has to satisfy both of them. So this is a 4. And now 2.9. 2.9 is between 2 and 3. And if you look at this, between 2 and 3 is here in this interval. And here is a close. If we are going normal to the x-axis, it's going to hit 3 down here. And if we are going, for example, in the y-axis, again, it's going to hit 3. So this is equal with 3. So this is one way how we can find out or how we can evaluate the least integer functions. And same thing in the previous video, I did how we can evaluate the greatest integers. So this is one of the methods.